rely on the rapid movement of electrical energy through dense power semiconductors. This energy transfer generates significant thermal loads. If this heat isn't moved away from the component, the resulting thermal stress can lead to immediate hardware failure. Survival for these systems requires a direct thermal path between the component and a heatsink, managing energy transfer across a microscopic interface. The reliability of these massive systems is ultimately determined by the integrity of a connection only a fraction of a millimeter thick. Even when metal surfaces appear smooth to the eye, they contain microscopic irregularities that prevent total surface-to-surface contact. This animated cross-section shows valleys between the surfaces. Trapped air pockets act as insulators, blocking heat from the cooling plate. Standard silicone fillers can release siloxanes under high heat. These gas particles outgas and coat adjacent circuit pathways, causing electrical interference. Furthermore, rigid thermal materials are susceptible to cracking. As components expand and contract during thermal cycling, these materials can lose contact with the surface. While two-part chemical fillers exist, they require precise mixing and secondary curing stages, which adds complexity and time to high-volume automated manufacturing. These combined chemical and mechanical limitations often force a trade-off between thermal performance and manufacturing speed. The MINORU SFPxx Series is a silicone-free, one-part thermal gap filler designed to address these specific points of failure. Its silicone-free formula maintains an outgassing rate of just 0.01% after 3 hours at 125 degrees Celsius, protecting sensitive electronics. Engineers can select the exact conductivity required, with models SFP02, 04, and 06 providing 2, 4, and 6 watts per meter Kelvin respectively. This range allows for precise thermal matching, ensuring that high-heat components stay within their safe operating temperatures without the risk of siloxane migration. The result is a stable thermal interface that remains chemically inert throughout the life of the device. Beyond chemistry, the material is engineered for mechanical stability, featuring high resistance to both sagging and cracking under stress. The SFP02 model is capable of a bond line thickness as thin as 0.03 millimeters, allowing for a tight, efficient connection between the heat source and the sink. This thin application and flexible texture ensure low residual stress on the board, which is necessary for the low-pressure assembly of delicate components. Because it is a one-part material, it dispenses directly from the nozzle, removing the need for secondary mixing or heat curing. Eliminating these secondary steps simplifies the assembly line and supports higher throughput in automated production environments. Once installed, the material operates across a wide temperature range, from -40 degrees to 130 degrees Celsius. The material's moderate initial adhesion also supports reworkability, allowing components to be separated and reassembled without damaging the circuit. These properties provide long-term stability for critical hardware, including power switches, industrial motor controls, and power semiconductors. By combining high thermal conductivity with a one-part silicone-free formula, MINORU SFPxx provides a reliable solution for high-performance power electronics.